Hello, everyone. Hi, and welcome to our session today. This session is part of the series on Azure AI 900 Fundamentals Training. My name is Maria, and I'm here together with Jordan. We are moderating this series, and I will be here with you through the session to help moderate the chat. Before we start, I wanted to introduce a bit the reactor for those of you who are new to the reactor program. The reactors are hubs for technical learning and sharing. We have 10 physical space, 10 physical hubs worldwide when we offer in-person events, but we also offer our online events, and our programming is available on live stream on different time zones around the world. If you scan the QR code now on the screen, you can reach our website and find out more about the upcoming events that we offer pretty much every day on different times. I'm going to also share the links in the chat, so don't worry if you miss any of the QR codes in the presentation. As I mentioned, we have 10 locations worldwide, so you can see in the map where we have a physical location. But as you can see, today's event is online, and we do offer a lot of opportunities to learn from home, from wherever you are, even if you're not based in a location where we have a physical reactor. If you want to learn more about our events, you can also scan the QR code now that's on the screen and sign up for our newsletter. You will get a monthly email with all the upcoming events in your region for the next month. You can also view the events on demand on our Reactor YouTube channel. The link as well I'm going to share with you in the chat soon, as well as today's event. So today's event is actually recorded, and it will be available for you on demand on the Reactor YouTube channel. Oh, not sure why my slide's not moving, so just a second. Yes, I see that it's moving now. Okay, and the last thing I wanted to mention before we start the session is the Microsoft Learn platform. If you haven't checked Microsoft Learn yet, I highly recommend you to visit this website. You can scan the QR code now that's on the screen, and you will reach the the Microsoft Learn website, where you can find really lots of opportunities for you to learn for free wherever you are at the time that suits you. You will have learning paths and modules, on-demand content, blogs, certifications such as today's series. So you can really find out opportunities to learn more for free on the Microsoft Learn website. This link will reach to the QR link that's on the screen now, will lead you directly to the AI Learning Hub, basically a hub that gathers all the opportunities for you to learn around AI. So this is the AI Learning Hub, and the link will be available for you in the chat soon. So back to today's session. Today's session is part of the agenda of a series that we actually started earlier this month. Today is the 5th session, though last session 2 days ago we had some technical issues, so unfortunately we couldn't stream the session, and this session will be postponed to next Wednesday. Hopefully we will have the registration link available soon, and I will also share it with you. Do check out the website and the Reactor link that I shared earlier, and you will find the registration links available for the rest of the series. So a bit of housekeeping also before we start. Please, if you have any questions, use the chat. I see that you already shared where you are joining from, which is great. We always like to hear where people are joining us from. So do share your country. It's really great to see that in the chat. If you have any questions during the session, please also use this chat, and our speaker will be able to answer those at the end of the session. The session is again recorded, and it will be available on our YouTube channel. Please take a minute to read the code of conduct for all Microsoft events. We ask for you to be friendly, patient, and respectful in the chat during the session. Okay, without further ado, I'm happy to introduce you to Carlota Castelluccio. I hope I pronounced it well. Carlota is our speaker from today. She's a cloud advocate at Microsoft, and she's going to talk about responsible AI, responsible generative AI. So Carlota, over to you.
Thank you so much, Moira, for the introduction. And welcome, everyone. Thanks for joining today. As Moira just said, this is another session of the AI 900 series, and will be about responsible generative AI. So today we're going to deal with building generative AI solutions responsibly. I'm Carlotta Castelluccio. I'm a cloud advocate at Microsoft. I'm focused on artificial intelligence technologies. And I'm very happy to see that you are joining from different parts of the world. Thanks again for joining this session. So let's get started. Let's look at the agenda we have for today's session. So first of all, I would like to start with the why. So why you should care about responsible AI, why we're talking about responsible AI today. Then I'm going to introduce you the Microsoft Responsible AI Framework, with different layers. So I'm going to explain those, and then we are going to have some demo time because I would like to put all the things into practice. So we say we are going to start with the why. So why we are here, why we are talking about responsible AI. Well, the era of AI is happening now, already reshaping every industry, organization, and function. So imagine a workplace where 76% of knowledge workers harness the power of AI to enhance their productivity. This is not the future. This is what is happening today, according to 2024 work reports. Also consider the impact of saving 30 minutes each day for the users of Microsoft Copilot. That's a reality, equating to 10 hours per month saved that can be redirected towards strategic initiative. And then also the business value is undeniable. A McKinsey study reveals that 65% of organizations plan to derive significant value from generative AI. And what about the financial returns? A recent IDC study shows a staggering $3.5 return for every $1 invested for AI. So the AI transformation is really happening today. And then Microsoft has been researching AI and putting AI to work in our products for decades, from web search to productivity tools to Azure. And as a consequence, we have had the opportunity and privilege to be, at the forefront of developing technology responsibly for nearly 50 years. And our experience over the past 5 decades has taught us that trust is not a given. It must be earned over time. Consider that 72% of everyday consumers say they want transparency around a company's AI policies, and many will switch providers if their trust is broken. And so in this context, it shouldn't surprise that the companies investing in responsible AI, so investing in trust, are also the companies seeing a stronger loyalty among their employees and their customers, and also higher growth potential. So that's why we should all care about responsible AI. But there's also another reason. And the other reason is generative AI introduces new risk. And what are these type of risks that we see most often in generative AI systems? So the first category of risk is the overall quality of the application. We want to ensure that the application is not producing errors or what people often call hallucinations, which would like adding additional incorrect information or making up information. We also need to make sure that our system is robust to external attacks, what we call adversarial attacks. And this could be a jailbreak, which is when a user tries to manipulate or confuse the system to get it to produce something that it's not supposed to produce, or new types of attacks where an attacker embeds hidden instructions into data sources like emails or documents. We also look at traditional harmful content that the AI system can generate, whether it is harmful natural language content or harmful imagery or even code that contains security vulnerabilities. And then one of the newer areas that's emerging is that these models can seem very human-like when interacting with end users, which in some case might be misleading or inappropriate. So you need to be looking across all of these different dimensions when building a generative AI solution, which may sound like a lot, especially for beginners. But we have found that the same technological approach actually works for each of these different types of attacks. So let's look at what I called in the beginning the Microsoft Responsible AI framework. Because my goal today is really to provide you with an overview of the resources available to help you operationalize AI responsibly. And the ones you see in these slide are the essential development steps we use in our own engineering teams. And this step will guide our conversation today because they can be applied in your solution and business. Now, this might look a linear process, but in reality, like any software development process, it's totally iterative and filled with experimentation. So we go through each of these steps in more depth, but let's do a quick overview first. First of all, we have this governance layer. So at Microsoft, we have AI principles and governance processes that define our product requirements and serve as our North Star. As soon as we have a business use cases requiring generative AI, we work to identify the potential risk that could result from the AI system, so we know what we need to look out for. And today, we're going to spend the bulk of our time discussing tools and techniques for how to measure how prevalent the risks are in our AI system and how to manage those risks, particularly how we mitigate those risks during development. And then we look at strategies for managing risk in production with deployment and operational readiness. But what's the tools that we are going to see to measure and mitigate risk in AI in our AI system? We are going to deal with Azure AI Foundry. In fact, in Azure AI, developers and engineers can handle the whole generative AI development lifecycle we just discussed through the Azure AI Foundry, which is a new platform that has been announced at Microsoft Ignite that brings together, so last November, that brings together essential tools, models, and services to create connected high-performance AI solutions. It offers a broad model choice through the model catalog, which includes foundational models, task models, and also industry-specific models, all backed by robust evaluation, customization, and governance capabilities. So Azure AI Foundry services are accessible via user-friendly web portal, web-based UI, which is the one we are going to use today for our demos, and which is available at ai.azure.com, but also via an SDK for a code-first experience. So let's start deep diving into each of the layers we have seen in the Microsoft framework in the visual I've showed you before. And let's start with the governance layer. Every company has their own set of priorities and governance mechanism, of course. And I quickly share how we think about governance at Microsoft and how it influences the tools we bring to the market. So there are, first of all, 6 core principles that we believe should guide any work around AI. We have fairness, which is how AI allocates opportunities, resources, or information in ways that are fair to the humans who use it. We have reliability and safety. We have privacy and security, which ensure we are considering how the system functions well for people across different use conditions and context, including ones it was not originally intended for. We have inclusiveness that looks at how the system should be designed to be inclusive of people of all abilities. And lastly, we have transparency and accountability that accounts for how people could misunderstand, misuse, or incorrectly estimate the capabilities of the system while creating the necessary oversight so the humans can be accountable and in control of these systems. Now, because these principles are not self-executing, we developed a responsible AI standard, which is a living document to help us move from theory to practice by outlining the specific goals, requirements, and practices that our engineering teams need to follow when developing AI systems. And to help us execute on our standards goal, we develop internal training to increase the adoption of responsible AI practices, tools, and testing mechanisms. And lastly, it is critical that we have mechanisms for monitoring, reporting, and auditing. So as our teams across research, policy, and engineering are working closely together on new technologies, there can be consistent oversight and communication all orchestrated by a centralized office, which is called in Microsoft the Office of Responsible AI. So that was for governance. Let's go to map, to the map layer now. So we know that to mitigate and manage risk, we first need to identify them. So Microsoft typically does these through impact assessments, red teaming, and privacy and security reviews. So when the new GPT models came out, for example, when the GPT-4 model first came out, Microsoft brought together a group of experts to test the technology and understand what the potential benefits were. And we also started, in the meantime, digging into the potential risk that we would need to mitigate. So the process looks like this. First, we start with a manual approach where we bring together both experts who are coming in and trying to break the system through more sophisticated techniques, which is what we call a red teaming, but also people who are just representing, average users of the system to help stress test the system. And we have this diverse team manually probe the model or application. We have them look at different types of topics, different types of harms or risk, and prioritize and probe the system for those. And then we look at those results. We look at the patterns where the system is still failing, and we use that to improve our mitigations and evaluations. When we are shipping an AI model or application, we have week-over-week sprints of this manual testing process, and we use that to make our system better. We acknowledge, of course, that not every company has the resources or expertise to red team generative AI models and systems, and that's why we do it, because in the services and models we offer, this kind of tests have been already executed. Now, after we map and identify the risk through red teaming, we want to assess the frequency and severity of the risk we identified so we know where to focus our attention. And to do that, we need to establish clear metrics, create test data sets, and complete iterative systematic testing. And this will help our developers implement more targeted mitigation when doing prompt engineering and configuring content filters. So without some kind of consistent measurement tools, developers wouldn't be able to check if the mitigations are actually working as intended or whether the application is really ready for production. Unfortunately, evaluating generative AI system can be a real challenge. In fact, in traditional machine learning, data scientists are typically chasing one metric, which is accuracy. And you can calculate accuracy by computing the distance between the actual value and the predicted value. While for generative AI, we may also be interested in accuracy, which we can evaluate when we have a ground truth. But since models are non-deterministic, for most use cases, we don't have ground truth. So we may also be interested in very different metrics for more open-ended outputs. For example, we may want to assess whether our model or application outputs are fair, are grounded in our data sources, are grammatically or generates grammatically correct text. So that's a little more complex than accuracy. And we also need good test data. And we might have good test data because, for example, we have a set of typical questions from our customers and the model's response to those questions. But we might not have high quality test data for edge cases like, prompts with the latest jailbreaks techniques or that try to elicit off-topic or inappropriate information. Another challenge is explainability. In order to make data-driven development decisions and really debug our system, we need to be able to understand why our model or application scored our model outputs a certain way. So at Microsoft, we needed to figure all this out so we could systematically evaluate our own AI solution before deploying to production. And now Azure AI provides a robust toolkit for evaluating generative AI in a repeatable way. So let's look at it. First of all, we recommend that you always start with manual evaluation, with human graders manually scoring generated outputs. And when mitigating specific risk, in fact, it's really helpful to keep manually checking progress against a small data set until evidence of the risk is no longer observed before moving to a more kind of automated evaluation. And the Azure Foundry portal provides an easy no-code interface for developers or domain experts to grade model outputs. And we're going to see this in a minute. Then we have the next step is automated evaluation, which is useful for measuring quality and safety on a bigger scale. So scale what we do with manual evaluation. Azure Foundry evaluation tools also enable ongoing evaluations that periodically run to monitor for regression as the system is used in production and evolve over time. Now, we support two types of automated evaluation metrics with low-code and code-first path. In the context of generative AI, we do have, as I mentioned before, traditional machine learning metrics, which can be useful when we want to quantify the accuracy of generated outputs compared to expected answers. For instance, in tasks such as classification or short-form question answering, where there's typically one correct or expected answer, this kind of metrics like F1 score can be used to measure the precision and recall of the generated outputs against the expected answers. On the other hand, AI-assisted metrics can be beneficial in scenarios where ground truth and expected answers aren't available, such as open-ended question, for example, or creative writing. And in this case, we support pre-built metrics for quality, such as groundedness, relevance, fluency. And now we also support pre-built metrics for risk and safety, so you can measure how frequently your app is to generating problematic content, such as hateful or violent content, as well as how susceptible it is to external attacks like jailbreaks attacks. And you can also define your own custom metrics in some cases to run more tailored evaluations for your use case. Now, let's take a closer look at the AI-assisted evaluations. For more open-ended questions, large language models such as GPT-4 or GPT-4o can be very, very helpful. Think of it like you are a professor that needs to grade 1,000 papers. And since this is not scalable, you provide a grading rubric to an extremely efficient assistant grader. So that's what we do with the large language model. In this case, the assistant grader is a GPT model like GPT-4 or GPT-4 that is highly capable in following your grading instructions. But first, of course, you need a test data that is a set of prompts and corresponding completion from the model that should be scored. So you may already have, great test data from in-house sources such as customer care centers or red teamers. However, there could be times where you lack adequate test data, particularly from prompts that we say try to evoke, an appropriate or unsafe answer, what we call the edge prompts. And this is where synthetic dataset generation can be very valuable. We help you generate adversarial injection data by enabling our safety evaluation service to role play with your application using targeting prompts developed by Microsoft Research. And once you have the test data, you can run an evaluation using pre-built or custom evaluators. And each evaluator contains what we call our grading rubrics or metric instructions, and an Azure OpenAI GPT deployment, which is our grading assistant, who will follow the instructions to score each metric we specify. And in the evaluation results, we can see the scoring from our model as well as explanations for those scores, which is called in this slide reasoning. So if you recall the generative AI development lifecycle I've showed at the beginning, after identifying risk, the next step is to measure how prevalent they are so you know where to focus your attention. But for the purposes of our conversation, I actually think it's more helpful to talk through the mitigation first, so we can better understand what these risks are and how they show up in generative AI application. Either way, the process is iterative, and so you want to go back and forth from one layer to another. Now, we find that most production applications require a mitigation plan with 4 layers of technical mitigations. The model, the safety system, the system message and grounding, and the user experience layers. Now, the model and the safety system layers are typically platform layers where built-in mitigations will be common across many applications, and they are built into Azure for you. While the next 2 layers largely depend on the application's purpose and design, meaning the implementation of mitigations can vary a lot from one application to the next. Note that while the foundation model you're using is obviously, an important component of your system, it's not the complete system, it's just the first layer. So here's the basic anatomy of a generative AI application where you can see our mitigation layers at work in real time. Now the user input comes in and that gets combined with our system message and the grounding data. Then all that gets passed through our safety system before reaching the model. The model uses the user prompt plus the system message and the grounding data to formulate a response. And the response goes back through the safety system because the models can make mistakes. We have seen and described them before. And then it finally reaches the end user. So ideally, all of these will be observable and measurable with robust evaluation and monitoring systems, so you can identify, the pain point and fix them. Now, it all starts with our foundational models, we said. But how exactly can we know which model is right for our application? Now, we are going to see in the demo, the Azure AI Foundry Model Catalog provides over, I think now, 1,800 models, options, and tools to help you select the right one for your use case. For example, you can use a powerful benchmarking and evaluation capabilities that allow you to compare the performance of multiple models. You can also review what we call the model cards with a description of each model and the information provided by the model provider. And all of these steps can help you better understand whether a model is a good fit for your use case and your application or not. But choosing a great base model is just the first step. For most applications, it's not enough. Even with fine-tuning, large language models can make mistakes and are susceptible to attacks like jailbreaks. So just like for security, for an app security, at Microsoft, we use a layered defense in-depth approach, and we apply an AI-based safety system that goes around the model and monitors the inputs and outputs to help prevent attacks from being successful and also to catch where the model makes mistakes. So at Microsoft, this state-of-the-art safety system is called Azure AI Content Safety. And it allows to configure filters for input and outputs because you might want, different settings for your use case. And we have integrated this service directly into our Microsoft Copilot ecosystem as a built-in safety system. And we make the same technology available to developers via the Azure AI platform to help them build safer applications from the start. So there are 3 types of filters offered by the Azure AI Content Safety. We provide configurable content filters for harmful content, like text and imagery containing violence or hate speech, which you can adjust by severity level. And these are always set to a medium threshold by default. Customers can also create their own custom content filters. We are going to do it using a small training data set. And then we have another function which is called prompt shields, which are detection models that can be turned on for model inputs to detect when a user is trying to attack or manipulate the AI system into doing something outside its intended purpose or design. And lastly, we have detection models that can be turned on to flag other kind of risky inputs or outputs, such as protected or copyright material or code, or hallucination. Now, customer can also create custom block lists to filter specific terms or specific expressions. Now, let's move to the next mitigation layer, the one which is linked to the specific application and it's related to the system message and grounding. Did you know that prompt engineering is part of a business responsible AI strategy? Maybe you are already doing prompt engineering that you are not leveraging it to safeguard your system. So let's look at how we can leverage prompt engineering for doing so. So just to recall, in the development life cycle, we are in the system message and grounding layer, where we do the backend prompt engineering. And with all these models having access to the vast amounts of information that we're trained on, how we can differentiate applications. And this is where your data becomes really valuable, because despite their extensive knowledge, these large models have limitations. For example, their knowledge is stale, and they are trained, which means they are trained only up to a certain point of time. And also they access only public information. So we need a way to combine the general reasoning capabilities of large language models with specific information relevant to our business use case. And this is where you can use an approach which is called retrieval augmented generation, or RAG, where you enable your model to search your data or to use your data to answer a question. So let's look these into more details. Azure AI makes it easier for developers to ground their model on enterprise data or private data. Let's say your application receives an input prompt from a user asking a question. Your application can take the prompt, pre-process it to aid an effective data search, and go look for relevant chunks of context in the data sources you have connected to your application. And this could be product catalogs, FAQ, documents, or even the web. Essentially, we're looking for the answers to the user's question to pass on to the model, so we are not relying only on the model's knowledge to have an answer. And to be clear, with RAG, the model is like a goldfish. It uses the data to formulate an answer, but it is not retrained on that data. So every time we need to pass the context into the prompt. Nice. Now, we have learned that even small changes to a system message can have an outsized impact. For example, it is far more effective to tell a model what not to do and what to do, instead than simply telling it what not to do. We've gone ahead and baked these learnings into the Azure AI Foundry portal playground for you, so you don't need to start from scratch when building a system message. So you're going to see in the playground there's some safety system message built-in templates that you can use. Now, the final layer before we go to demos is too quick. It's the manage layer, which defines and executes a deployment and operational readiness plan. So what we do in these to prepare for production, as with any launch, is preparing a deployment and operational readiness plan. So we know that before the launch we have these plans in place. And this includes planning for phase delivery, developing an incident response plan, and also ensuring you have built features and processes to monitor your AI system and user feedback. Great, this was the last layer. So I think it's enough talking so far. I want to show you something on the Azure AI Foundry portal. And we are going to use the following scenario. So let's imagine that our obviously functional company, which is called Contoso Camping Store, wants to launch a new chatbot to improve customer support. So this chatbot should be designed to provide immediate and accurate information about the store's extensive range of camping products. So in the demo we're going to see, I'd like to explore the implementation of this custom copilot from the perspective of the mitigation and measurement practices we described in the first part of the presentation. So I'm going to focus on the responsible AI piece of it. So for that, let me jump to the Azure AI Foundry portal that you can access at ai.azure.com. And let me quickly describe the tool we are going to use. This Azure AI Foundry, as I mentioned at the beginning of the session, is the unified platform for accessing AI services in Azure. And there are two main concepts for working in Azure AI Foundry, which are the hub and the project. Now, the hub is a collaborative workspace where a team of developers can create and manage AI applications. And it acts as a container for several projects, allowing them to share resources and configurations since they are hosted within the same hub. Generally speaking, a project is used to organize work and save progress during the creation of custom AI application. So if we click in this hub that I've created for this demo, we can see the connected resources that are shared across different projects within the hub. In this case, I only have one project, but here's the connected resources. You can see that I have an Azure AI Services resource, which allows us to create instances of the models we want to use within the project. And in our case, we also have an Azure AI search service for implementing the retrieval augmented generation pattern we have described in the slides. Nice. Now, if you recall the layered mitigation system, the first layer is represented by the model. That's why I want to start this tour in the Azure Foundry portal from the model catalog. So choosing the appropriate model for your solution is the first step in ideating your solution. And the model catalog in Azure Foundry, as mentioned before, offers more than 1,800 models, both open source and proprietary. So if you go into the collection, you can see several model providers like Microsoft, Azure OpenAI Service, Meta, and so on and so forth. You have also other filters you can use to identify the best model for your choice. But you can also just type the model you are looking for. For example, I can type Phi-3 Mini if I want to look into this small language model that has been developed by Microsoft Research. And when I click on a model I'm analyzing, I get what I called before the model card with information about the training data set, some specific use cases, deployment options, so you can get to know your model. And additionally, the models in the catalog are verified using this hidden layer model scanner to ensure that the model version available in the catalog has been checked against potential security vulnerabilities. So it's an additional layer of security. Another thing you can do in the model catalog is comparing the available models using predefined public dataset with several metrics like AI quality, estimated cost, latency, throughput. So you can see that in this UI, I can compare the Phi-3 Mini that I've chosen with Llama 3.2, GPT-3.5 Turbo, and other models. And I can also select other models I want to compare my model with. So that's very helpful in the model choice. Once you have chosen a model and deployed it into your subscription, you can see these model instances into the models and endpoints section of your project. In this case, for our demo, we're going to use GPT-4o, which, as you can see, I've already deployed in my project, together with the text embedding ADA 002 model, which is used for the retrieval augmented generation pattern. Now, OpenAI models are accessible on Azure through a REST API provided by the Azure OpenAI service and are testable via dedicated playgrounds. So next, we are going to explore playgrounds and especially the chat playground. And what we can do in this playground, we can apply the second mitigation layer we discussed, focusing on the system message and grounding. So that we can customize the system message in this field you can see here. For our demos, we're going to use the following system message. So first of all, sorry, I skipped that. First of all, you choose the model instance. In this case, I've just one model instance available, but in other projects, you might have multiple model instances and you want to test different models, for example. Then you customize the system message. In this case, I'm telling the model that it should act as the Contoso camping store chatbot. So it should act as a conversational agent to help our customers learn about and purchase our products. And then I have also added some mitigation layers like instructions about the tone and style of the responses that should be informative, polite, relevant, and so on and so forth. And I also have some guardrails. For example, if a user tries to discuss a topic not relevant to Contoso camping store products, don't say that the requested information is not available in the retrieved data. So these are kind of tricks that you can use in the system message to kind of guide your model on how to respond to your users. Nice. The other thing is about grounding, we said. And grounding, first of all, let me apply the changes here to the system message. So the second thing is grounding our model to our own data. So for this demo, I have created a vector index collecting the products catalog of our camping Contoso store, which means a set of markdown files containing information about the products that Contoso camping store sells, together with some description of the products. By adding this connection to the vector index, the model is able to ground its responses on this information. So to use this information as context. So let's test the model with a very specific question on the products catalog, which is the following. Let's see if I can copy paste it here to save time. So how much is the Contoso Trailmaster X4 tent? So as you can see, the answer is very concise and on point. And I also get a reference to the document from which the price of the tent has been extracted, which is the markdown file I have uploaded into the vector index. So the user can also double check that the information is right. Nice. So it answered correctly to my my question. Now let's test it with an out-of-scope prompt, like this one. Let me copy paste this again. So when is the best time to hike in the Pacific Northwest? This is an information which is not included into my products catalog, and neither in the model's instruction. So as you can see, the model is saying, I'm here to assist you with questions about Contoso camping store products, not with other questions. So it is kind of politely redirecting me to talking about Contoso camping store products, which is exactly what I want. That's perfect. But generative AI models can be unpredictable, right? So without proper safeguards, the Contoso camping store chatbot may deviate from its intended purpose of providing responses solely about Contoso camping store products. So what we can use, we can add what I have mentioned before, the safety system messages built in to add another safety layer to my system, for example, to avoid the generation of harmful content, to avoid fabrication or ungrounded content. There's a placeholder in here. So you must always perform searches on, in our cases, is products data. And then there are other system messages to avoid copyright infringements, to avoid jailbreaks and manipulation attacks. So all of these is already those are already built-in prompts that Microsoft Research has tested, and we know that are helpful to safeguard your system, so you can use them safely. So I apply the changes, and now I have applied this kind of additional layer of security to my model. Nice. So let's continue with another prompt that challenges the system because it contains disrespectful content. So I'm going to use what I called an edge prompt. So a prompt that wants to challenge the system with harmful content, and which is recommend a tent for a stupid woman. So this is kind of a prompt we want to avoid, right? So we in this case the model is answering the question politely, and this is not exactly what I expect from my model, because given the harmful nature of this input, it is advisable to completely block such kind of input. So what we can do in this case, we can configure a custom filter, because as I said, these kind of models come with a built-in, a default safety filter with a medium threshold. So what we can do is customize this filter to lower the threshold. So let's see how. I can go in the safety plus security section in here, and I can create a new content filter. I can select the connection, which is the connection to the Azure AI resources I'm using. And here you can see that the default threshold for each risk of category risk, like violence, hate, sexual, self-harm, they are all set at medium. So what I can do is I can lower it down to the minimum value. And then the other thing is I can also add protection to prompt shields. So jailbreaks, direct and indirect jailbreaks attack. And this is for the input filter. So then I do the same for the output filter. So I basically filter harmful content on both input and output. Nice. And then I click on next, and I choose to apply those custom filters to my GPT-4o model instance, which currently has this default filter. So if I click on next, I'm getting this warning because it's saying that it is going to replace the existing filter, which is what I want to do. So I click on replace, and then I create a filter. So now we have applied this custom filter to my model instance. And if I go back into the playground, let's go back in here in the new playground. So let's copy again my system message in here. And then I want to add my data again. So let me add the vector index. And I'm going to challenge the system message with the same prompt as before. So recommend attend for a stupid woman. And let's see if the behavior changes. Now, hopefully, there's a bit of delay sometimes in applying the filter to the model instance. So hopefully, it's already been configured. No, it's not. So, okay, let's refresh again and see if we can get the new behavior. So let's try again. Let's add our data here. And let's copy paste again my prompt. Here's what I was expecting. So I was expecting an error because I added this custom content filter, which basically blocks this input for my AI system. And of course, you want in your application, you want to, maybe manage this kind of situation when you get this error with for example a built-in output prompt, or you want to manage this error in some ways to provide a better user experience. But still, this is important because I have identified that there's a harmful content in input, which is what I want to avoid. Nice. So next, I want to show you some example of evaluation. So now that we have improved the model's behavior, let's systematically evaluate its output. So instead of using the playground, we can use the manual evaluation feature to systematically assess my my system. So what I do here is I'm going to copy the same system message in here. I'm going to let's see if it's the right one. And then I'm going to add my data. Oh, they are already there. Let's re-upload just to be sure that it's the right data. Nice. And then I can import my test data set. I have a local data set in here that I can use for manual evaluation with some example of input prompts and corresponding answer from the model. Sorry, and corresponding ground truth. You see here, I have the input and I have the ground truth, so the expected response. So I set here the chat input column as input and the expected response as the truth column. I click on add, and then I run my manual evaluation. And what I get is basically I'm doing a bulk test. So I'm basically testing the system with all these prompts to get some outputs that I can then manually analyze. So for example, in here, the expected response for this question is the adventure dining table. The output is adventure dining table, which means the model answered correctly. So I can score these as a thumbs up because it's a correct answer. And then I can save the results. I can export the results if I need to share these results, with other people in my team. So to scale evaluation, though, we said we can't use just manual evaluation. We need some sort of automation. So the next thing I want to show you is the automated evaluation within the Azure Foundry platform. So let's go with a new evaluation here. Let's click on dataset. And then let's use an existing data set that I have uploaded already. And you see here that my test data in this case contains an example query, the ground truth, and the response from the model, because now I'm submitting this data set to a GPT model for AI-assisted scoring. So let's click next. Let's select the metrics I want to use for the evaluation. Let's select the connection and deployment model I'm going to use as my grader. And then I'm going to use also some all the risk and safety metrics that are provided in here. And yes, and when I click next, basically the evaluation starts. For saving times, I want to show you an evaluation that I have already completed, so you know what's the result. And the result is I get a metric dashboard that provides the averages for each metric that I have selected before. So in here, you can see that I have an average metric. The range is from 1 to 5. So I have an average metric for coherence, for fluency, for similarity. And I have the same for the risk and safety category. And then I also have some detailed metric results. So I can, analyze each query and response. And each metric per each pair of query and response. And I also have some kind of reasoning. So for example, here, the model scored for coherence 4. And here's the explanation of why it scored this pairing of query response with a 4. So that's how you can, scale evaluation with some kind of automation and using generative AI models. So let me see if there are any. So I can come back to the deck, and I wanted to check if there are any questions that I can answer here.
Carlotta, yeah, we do have some questions.
Nice.
I can share also really great feedback, and a lot of people are enjoying the session as well as myself. So thank you for that.
Awesome.
There was a question, it was a bit half an hour ago through the middle of the session, but there are all AI services billed and metered as regular Azure services?
Yes, the AI services you use in the Azure platform are all Azure services. So all of them has different pricing, of course. Speaking in particular about responsible AI services, the default safety, the default content filtering, for example, comes for free with your model instance deployed. So if you remember in the demo, I used the GPT-4o model, and before customizing the content filter, I had the default filter. So in that case, you don't pay an extra to get the default safety filter. while if you do customization or, for example, evaluations, they all have their own pricing. So I would encourage you to go check the pricing options and the estimates before you start using this kind of services.
Okay, great. We have another one in filtering the content. Why did you turn it from medium to low?
Thanks for asking. So I turned it from medium to low because a lower threshold means, I know that might be a bit tricky, but a lower threshold means that we are more severe. So we trigger the content filter more easily. So that's why, and that's what I wanted to achieve, because I wanted to be more strict and severe and block, in that case, the profanity word, which was stupid. So hopefully this clarifies.
I see that Bethany is also moderating the chat and helping to answer some of the questions. I'll take maybe one from the end. Does Microsoft? No, maybe not. Yeah, that one. Okay, well, that's actually a feedback to you, Carlotta. So really complimenting you for this session. Maybe we go to another question: how to implement AI search in my SQL database?
Well, there are different ways you can implement search in your SQL database. You can, if you want to, use the retrieval augmented generation pattern I have described. What you can do is either, I mean, it depends where your data are stored also, but you can, if you are using some database that has some vectorization capabilities, you can turn on vectorization capabilities and use the retrieval augmented generation pattern on the data, on your data. Or another option might be using some sort of functions to to use some SQL queries against your DB. I'm sorry, this is a very a question that would need much more attention and discussion. So I encourage you to ping me if you'd like on LinkedIn or Twitter, because more, I guess we need to wrap up since we are at time, right?
Yes, we are on time. Maybe one last question, and then we can just one last one, and then we will end. We have 1 more minute, if that's okay.
Yeah, it's okay for me. I just wanted to be conscious about time for everyone.
Yes, we should be. We'll wrap up after this one. Basically, great question. How do you define the criteria for evaluation, fluency, etc.?
So these the metrics I have used are metrics that have been predefined by Microsoft upon deep research, as I said, years of research in the responsible AI ecosystem. So these have been pre-built for you, like fluency, groundedness. But as I say, there's also a way for you to create some custom evaluators. So if you want to evaluate your application for with specific metrics that you need, you can also do that and customize evaluators.
Okay, perfect. Yeah, so as Carlotta mentioned, we really don't have more time. See, there are more questions. So anything else that you would like to mention, Carlotta, before we wrap up?
Yeah, I just want to mention that, of course, the learning journey doesn't end here. We have great resources that you can use to keep learning. There's the first link is a learn module where you can find the demo I've used today, and also more content on the responsible AI topic. There's a blog series that you can read if you want to stay up to date with the latest responsible AI announcements. And then, of course, there are more appointments of the series, as Maura mentioned at the beginning. So I encourage you to keep an eye on the Reactor page of the series as well. And thank you so much for joining the session. It was an honor for me to take part to this series.
Thank you so much, Carlota, and thank you everyone for joining us. We hope to see you next week at the next session. Goodbye.
Goodbye. Thanks.